Hi everyone, I'm gonna start solving LeetCode questions and put the video here on this channel. I'm gonna do that contest by contest. So after the end of each contest, I'm gonna try and capture video for the solution a few hours after the contest so you can come here and watch the videos that you are curious about and hopefully get some insight. And for the problems that you were able to solve the problems during the contest, take a look at the last few minutes of those videos. I'm going to come up with some variations of the problem, like how you can change input or what other questions can you ask in that space, so to make it more interesting. And you can also come up with your own variations of the problem and comment them here. I like to have a collection of all the variations that you can come up with, and we can discuss about the solution of each variation. This is one of the problem solving techniques that I learned in university, that whenever you solve a problem, try and change the problem and see if you can solve the new version. And by doing this, you're going to improve your problem solving techniques. Let's take a look at the first problem of the contest. It's a 3-point problem. These problems are usually simple. So this one is also a simple one. We are looking for the maximum area of the longest diagonal rectangle. We are giving the dimensions of the rectangle, the width and the length, and we should return the area of the rectangle that has the longest diagonal. And if there are multiple rectangles with the longest diagonal, we should return the area of the rectangle having the maximum area. So if there's a tie, we should return the one that has the maximum area. So here, the only thing that I can mention about the solution of this problem is double comparison. So it's a good idea to avoid comparing doubles as much as you can. So here, in order to find the rectangle with the maximum area, we should be comparing diagonals, and diagonals in essence are doubles. But we can avoid that. Let's see how we can avoid that. Let's say we have two rectangles. One of them is this one, A and B, and this is the diagonal, and one of them is this one, C and D, and that is the diagonal. So the diagonal of the first one is a to the 2 plus b2, and this diagonal is c2 plus d2. And if we want to compare them, if we want to say, hey, is this less than that, we are comparing doubles. But because both sides of this inequality are greater than or equal to 0, we can get rid of the a square root. So we can compare a2 plus b2 with c2 plus d2. And yeah, in this way we are going to be comparing integer. This is definitely integer, and also this is integer. We can go ahead and write the code, and then at the end I'm going to come up with some variations for this problem. We need some variables to keep the maximum area. So int max area, we're going to set that to 0. Int max diagonal, we're going to set that to 0. And then we are going to do, I'm going to call this longest diagonal. And I'm going to do a for loop auto r dimensions. Okay. And then we have R0 and R1, right? So the new diag is going to be R0, times R0 plus R1 times R1. And we can compare it to the existing diagonal. So if and we can also have the area. So int new area is going to be R0 times R1. This is the area a times b in this example. And we can compare the new diagonal with the longest diagonal so far. So if new diagonal is greater than the longest diagonal, we are going to keep track of that. So longest diagonal is going to be new diagonal, and also we are going to keep track of the area. It's going to be new area. Else, if new diagonal is equal to this, we're going to just update the maximum area. Maximum area is going to be max of new area and max area. That's it. So if it's equal, we just keep the maximum area. So, and that's it. And we just return the area, I think. Yeah. Return max area. Let's see how we are doing here. Yeah, 48. Let's try all of the examples. Yeah, that's working. Let's just submit and accept it. Okay. That's it. The first problem is easy. Let me come up with some variations. So the first variation is, what if instead of one area, we need a list of the rectangles in decreasing order of the length of the diagonals? Like in this example, if we are giving this, if we are given this input, let's take a look here. So the first one, the diagonal of the first one was 9.4, and the second one was 10. So we want the first one to be returned first. So we want the output should be something like this: 8, 6, and then 9 and 3. So we need a list of we need a list to be returned. It's not just a single number. So this is a simple variation. The key to solving this variation is defining an operator. And I have asked ChatGPT to come up with code, with the right code for 3 different languages: C++, Python, and TypeScript. Let's take a look. So I have asked ChatGPT, how do I define an operator to sort a vector of dimensions of rectangles in C++, Python, and TypeScript? And I've given the sorting criteria should be the length of the diagonal in decreasing order. And if there is a tie, it should be sorted based on the area in decreasing order. So as I said, the key is in defining an operator. This is the operator, and then we are going to pass it to the sort function. This is C++. This is how C++ works. You define a compare function and you pass it to your sort function. And for Python, you can have a lambda that you can actually compare the objects based on this criteria. And then for TypeScript, it's very similar to C++. You have a function. All of them are the same, basically. But the key here is to be able to define an operator, a comparison function. This is the first variation. So the next variation is to think, what if we have different shapes? Like, what if input is our circles? Instead of rectangles, let's say we have circles. How does your solution change in this case? Does it change at all, or not? A little bit. Or instead of circles, you can think of cubes, or you can think of triangles. All of these, and think if you can come up with a version that the solution is gonna vary a lot. And when you're thinking about coming up with new variations, you can think what you have in this problem. You have rectangles. So go ahead and see what you can do with rectangles. The next thing that came to my mind is that let's say we have two rectangles and we want to find the shortest distance between these two rectangles. So this distance. How do we calculate A? So we should find if the two rectangles collide or not, because if they collide, the answer is 0. If not, we can just find this distance and get, so if this is C and this is D, we need the square root of C2 plus D2. This is the other one. Now I can come up with another one. What if we have three rectangles and we have A, we have B, and we have C. And we want to jump from A to B to C. And this is a variation of this problem actually. What is the distance that we are gonna jump if we want to do that, the shortest distance? So that's gonna be something like this. So if we solve this problem, we're going to be able to solve this problem. If we want to go from A, yeah, to B and then to C. This is another one. The other one could, what if we can think of a graph that the rectangles are just the edges? Let's think about it. So we have some rectangles and we want to go from, we are here, let's say. This is rectangle 1, and we want to go to rectangle E. What is the shortest path from A to E? So as you can see, this problem is a variation of this problem. The only difference is that here we only had 2 rectangles, but here we have n rectangles. And so on and so forth. You can try to change the shape here as well. So instead of rectangles, what if you have circles? What happens there? For each variation, you can pause and think about it. And if you have any questions, I'm going to answer them in the comments. Thank you. This is the end of video 1. See you in video for the problem 2.